Good day to you. Hope you all are well and keeping safe. So, we are going to start the distant remote learning method in which I will upload videos, short videos of the courses, the lectures that you will watch at your time, and followed by videos will be a brief activity that you will have to do for a week. So, in a week, I will broadcast two videos for you, and then after watching those videos you are supposed to write answers to these questions, which I will enable in the SULMS. So let us start our lecture, which is on purchasing and inventory management. Course aim and objectives are known to you. The topic of today's presentation is inventory management, independent demand. Earlier we have already covered dependent demand case, and I broadcasted it using the big blue button technique. So this time I have resorted to a different video which can be saved for a longer time. So we will talk about the questions regarding to independent demand and how we manage inventories here. In case of dependent demand, you have already seen how inventories can be forecasted and built. How demand can be forecasted, and based upon demand how inventories can be built and what decisions can be taken. So here we will talk about a different concept that is called economic order quantity, because organizations wants to know how much to order and when to order. And when we answer these decisions as a manager, purchasing manager, this is our operating doctrine: how much to order and when to order. So organizations order certain quantities. If they order small quantities, the cost of ordering becomes high. If they order more quantities, cost of storage or carrying becomes high. Second thing, when to order. If they order every time, every day, that is again having repercussions on cost. So they need to decide how much to order and when to order. So for how much to order, you have to have some basic EOQ model. So if you go back here and I show you this slide. So how much to order is based upon economic order quantity models. We can calculate it. Here we want to determine the order size, which is determined by EOQ. So EOQ, economic order quantity model, or models, there are many, identify the optimal order quantity by minimizing the sum of certain annual costs that vary with order size. So the aim is to minimize the cost of inventory. And there are three order size models, sorry, just correct it. They are described like: one is EOQ model, simple EOQ model. Second is EOQ model with non-instantaneous delivery, when the delivery is not instantaneous, means when delivery are not received at one time. Like when you want to order 1000 items, so 1000 items will all arrive in your godown. That is instantaneous delivery. Non-instantaneous delivery means you are manufacturing or they are being supplied to you at a certain rate, in which there is a production of the items happening, they are being supplied to you at the same rate, like the production rate. And third models are commodity discount models. So this video will break up in two parts. So in this particular session, I'm going to talk about the EOQ model only. So let us understand the simplest of the three model, that is called basic EOQ model. So in basic EOQ model, if you see, it is used to identify the order size that will minimize the sum of the annual costs of holding inventory and ordering inventory. I told you when you order, there are two costs. If you order frequently, you have ordering cost. If you order more, you have holding cost or carrying cost or storage cost. So these two costs, ordering and holding, they define the total inventory cost, and you want to minimize these costs, and EOQ model helps you to know how much you should order. So what is happening here? This is the figure which mentions you about the inventory cycle. Here you can see that when you receive, you have zero inventory here. When you order for Q quantity, instantaneously you get Q. So your stock from zero builds to Q. Then you use the inventory. After a certain point of time, your inventory again reaches to zero. Since it is instantaneous replenishment model, whenever you order, you get whenever you receive the order, you get a full amount Q. So again, your inventory becomes from zero to full Q, and then it goes down slowly and slowly as you consume it. So this is the typical behavior of the instantaneous delivery model. And here, if you see this point, this is called reorder point. At this point, you order. As I told you, inventory management needs two decisions at its basics. How much to order, that is answer is given by economic order quantity, and when to order, it is known by reorder point. So at this point you should order. When you order at this point, you will receive all the item at this point. And the difference between the time when you are placing an order and when you are receiving an order, that is called lead time. That's good. Let's move forward. Now I will tell you how we calculate total cost and how its behavior is there in total inventory model. So total cost in a simplified way, we can say that it is this addition of annual carrying cost of inventory plus annual ordering cost of inventory. So total cost becomes is equal to, this is quantity divided by 2, that is average inventory. So what is your average inventory multiplied by holding costs per unit? How much will be the cost when you are storing it in a go down? Plus demand, your annual demand divided by quantity which you are ordering, and then multiplied by the ordering cost, like the expense which will happen when you will order this quantity. So total cost is equal to Q by 2H plus D by Q into S. You can read it at your own pace later. So what is the behavior of the inventory cost? You can see it here. Okay, at this side, if you see, this side is the quantity and this side is the cost. Okay, so there are two curves first. This is the first curve. Okay, so cost is low here. As you are ordering more, okay, the cost is increasing. So when the quantities which is being ordered is increasing, cost is increasing. What is this cost? This cost is called holding cost or storage cost. If you store less, you will have low cost. If you store more, you will have high cost. Then this curve is there. This is ordering cost curve. Ordering cost means when you order less, okay, means you are ordering less, means what is happening? The cost is going, means number of orders are less. When quantity is less, number of orders will be more. That means the cost of ordering will be high. When the quantity is high, ordering will be less because you are ordering only one time. Suppose your order size is big, so means you don't need multiple orders, so that means ordering cost will be low. So ordering cost reduces as you increase the quantity size, order size, and this is the total of this, means the holding cost and ordering cost becomes total cost, this one red curve. And you see that When you plot this curve, the minimum cost is here, total cost, and this cost is for a certain quantity. This is the behavior of the cost curve, and this quantity is called EOQ, economic order quantity. This is very important for you to understand. Okay, so how we calculate EOQ? There is a formula for that. So this formula says that the total cost curve reaches at its minimum where the carrying cost and ordering cost are equal. If you see in the previous curve, you will see at EOQ, carrying cost and ordering cost, they are equal. And using this and differential calculus, we can know that this is the formula for EOQ. EOQ or Q optimal is equal to square root of 2 into demand into ordering cost divided by holding cost or storage cost also it is called. So if you know this formula, you can calculate what should be the quantity that you should order to reduce the overall total cost. There are other formulas also. For that you can refer to my long slides, which if you want. So for the time being, if you understand this, you will not find difficulty in understanding other concepts. So this is the question, that how we calculate economic order quantity. That you will do, and I'll place an activity in SULMS that you have to do, but just let me explain to you how you will do it. This is a case of a distributor of tires which is selling tires, and its demand is 9,600 tires in a year. Okay, and annual carrying cost is $16 per tire, or you can say real per tire. You can understand, you can change the unit. And ordering cost is $75 in this question. So when you know these three figures, this is demand, this is carrying cost, and this is ordering cost. So then you can know that what should be the Q optimum or economic order quantity is equal to square root 2 demand multiplied by ordering cost divided by carrying cost. 2 demand, how much? 9,600 multiplied by ordering cost. What is ordering cost? 75 divided by holding cost or carrying cost. That is how much? 16. So 16 will be here, this as arrows indicates. So if you do that, if you solve this by using your calculator or mental maths, you will be able to get the economic order quantity, which will tell that this amount of tires should be ordered by this distributor in order to bring the total cost of inventory down. I hope you understand this concept. These are the references in the slides which passed by. You can always open them from your slides on SULMS. So thank you very much. It was a pleasure to have this session with you. We meet now in the next session. So please pay attention to this session and let me know about your feedback. If I am too fast, please tell me. I will become a bit slower in my next presentation. And after the next video, you are supposed to attend the activity that is there, that will be there in the SULMS, and you can answer it within the given time. Okay, so please read my announcement or message therein. Thank you very much. Wherever you are, stay safe. Best regards to your families from Sohar University. Thank you.